So, thanks for the nice welcome, Bob. Ladies and gentlemen, dear friends, I feel honored and pleased for the chance presenting my idea of an international space university in a plenary session on this conference. After an entrepreneurial career in the real estate sector and a MBA plus DBA in space program management, I have now a 12 years background as a professor. Furthermore, I was founding professor and later president of this institution, Hamburg University of Applied Sciences, a distant learning university in Germany with over 40 study centers, mainly in Germany, but also in Austria and Switzerland, and in the USA, there in Louisville, Kentucky. During my 4 years term as a president, this university grew steadily to the biggest private university in Germany with presently over 11,000 students. Currently, I'm serving as managing director for our Albstadt-Sigmaringen University Institute of Executive Education in Germany, where we currently develop and offer postgraduate executive master programs in the field, mainly in management information systems, but also IT and cybersecurity. And the most important thing, Bob mentioned it already, I was an enthusiastic founding member of the Mars Society on our founding convention, now exactly 15 years ago, here in Boulder. After this historic event, I co-founded the German chapter of the Mars Society and served as its first president and was also a member of the steering committee until I was named president of this Hamburg University. So let's go to the idea of an international Mars University. So this is my first presentation of this idea at the Mars Convention, the International Mars Society Convention. During my academic career, I especially was always interested to be involved in developing innovative programs together with different faculties. Even as a president, you are not an expert, but you are a coach for some developments. Innovative not only in the term of the content we have to deliver to our students, innovative also in the sense that we should explain the goals and learning outcomes of the respective academic program first before we go into the details. This is again our very first task in the academic world, I think, before we secondly should do an initial overview project together with our students where the solutions for a typical research, design, development or management challenge later in the graduate's career should be developed. So in doing so, we should explain our students why they need to go into what kind of basic subject or detail like chemistry, thermodynamics, technical mechanics or managerial accounting to manage a project later in their career or to get the work simply done. That means that every detail of a basic subject should be justified during the development of a study course so that we don't have too much details or we avoid that we lost the goals out of our side. With this method, we also are able to keep up the original interest of the students for the chosen program, and we are able to motivate them to get through often some boring, abstract and complicated basic subjects. The goal-oriented or top-down from the curriculum to the basic top-down approach is also a destination-driven approach in our terms in the Mars Society. But how can we keep up, especially the motivation of science and engineering graduates in the present academic world who choose the subject with the original motivation to contribute, for example, significantly to a human Mars exploration and a sustainable growth of a human Mars presence later on in their career. Presently, the most academic programs on a postgraduate level in the field of planetology and aerospace engineering in Germany, but mainly also internationally, are not Mars specific and often without any exploratory spirit, not destination driven. Also, not only industry is not destination-driven. The academic world often is also not destination-driven. Especially some German aerospace engineering master programs are right from the first semester focused on technologies and subsystems. I brought an example with me from a typical curriculum in the first semester of a German master program in aerospace engineering. You can see this on the slide. This is numerical methods in aerospace engineering 1. That means that there is a follow-up in 2, 3, and 4. Structural dynamics, system design 1, guidance, navigation, control, aerodynamics, thermodynamics, and aero engines, space technology, and which is especially important for Germany, sustainable energy and traffic systems, which has only little to do, in my point of view, with space technology primarily. So the consequences are that this leads often to an abstract and overcritical approach of later researcher and engineers to destination-driven missions, or especially to human Mars missions. The ultimate goal to get somewhere, which originally motivated the student decision for a planetology or aerospace course, often disappears during the studies, and graduates start thinking from the subsystems or technology perspective and not from mission goals and mission efficiency. Those graduates often develop a critical distance to destination-driven missions later in their career. We even experienced this with some Mars Society members in Germany, that they are no longer available for the society. So furthermore, even in the postgraduate programs, plenty of time and money is often wasted in useless and unfocused basic and general subjects. Therefore, the postgraduates, if they made it through this jungle of basic things, often still need to undergo a long and expensive trainee phase later on in their professional life. Often in technical master study courses, there is an absence of any program management lessons, which is also important for later engineers. So to prepare for human Mars exploration and the sustainable presence of human researchers and settlers on Mars, and this is our goal here in this society, we need special Mars-focused Master of Science and Engineering programs, and to organize and integrate this, an international Mars University, or simply IMU. So IMU is only the abbreviation for some other things in space, so therefore I choose this initially. But how could we create a world-class university without investing hundreds of millions of dollars in campuses, classrooms, office buildings, research labs, computer pools, libraries? You see a picture here, fixed employed world-class professors, research assistants, and a parallel universe of administrative staff, including real estate and facility managers, and last but not least, the president with a nice salary, nice car, and his driver. So we should not build something like this. I quote a little bit from the case for Mars, Death Star or Battlestar Galactica-like universities. Here, another nice picture I found on the internet. We have to intelligently use already existing academic resources and networks through a cooperative approach. Almost everything we need for an international Mars university is already there. Despite my aforementioned heavy criticism of the structure of some postgraduate programs, there are plenty of Mars enthusiastic institute directors, also professors, often individuals, researchers, and in brackets perhaps some administrative people in many universities and other acknowledged research institutions all over this world. But how could we manage a goal-driven integration of all these resources without building a Battlestar Galactica of a university? We refer to this a little bit later. Let's first develop a vision for our university. According to strategic management guidelines, a vision statement should characterize realistically, the future identity of an organization. It should simply answer the question, what do we want to become? The most important thing of this vision is that every strategic and operational plan and every action has to be consistent with this vision statement. So my suggestion for an initial vision of the International Mars University is the best of the Earth for Mars. We should like to establish a world-class university which significantly contributes through their stakeholders to a sustainable and growing near-term presence of humankind on Mars. So, of course, a focus on human Mars exploration. So we don't want to exclude robotic exploration, but we see this mainly as precursor or assisting technologies for human Mars exploration. So the next thing we should develop for an international Mars university should be the business model, the initial case of this university, otherwise called mission statement. So our students in this International Mars University should be characterized first. Who is that? Who should study at this university? Most important and thus mentioned first are our students. They should be the starting point and the goal of our thinking and of all our activities. And we offer our postgraduate master programs to math enthusiastic graduate students in the field of natural sciences and engineering. So graduates, so in the European terms, graduates is somebody who has finished, of course, his bachelor's degree. It's the same, I think, in the US. Graduates with a bachelor's degree in the field of mathematics or natural sciences can attend a Master of Science program in, my suggestion, interdisciplinary Mars research. I'm getting to the structure of the programs later. Graduates with a bachelor's degree in the field of engineering, mechanical engineering, electrical, civil, or aerospace engineering can enroll for a Master of Engineering program in Mars Systems Engineering. So even the programs should be Mars driven. People already holding a master degree should enroll for Mars-specific master programs at the International Mars University by importing already achieved credit points on a master study course level of similar modules from the original master degree into the program. So the most interesting thing is, of course, what kind of academic program are offered. So please recognize that I'm an interested layman in science and engineering. So, but I think often it's interesting to hear those kind of proposals, because experts are often sometimes apologize partly for this, but they are often sometimes trapped in their world. Yeah. So I want to make a proposal, but you have, of course, the right, and I would like to encourage you to criticize this in our later discussion. So I quoted from Dr. Carol Stoker. A first vision for this Master of Science in Interdisciplinary Mars Research. So, an interesting quote: the scientific exploration of Mars is nothing less than opening another world to scientific study. It's a little time ago, but it's still actual. And what kind of modules should be in a master, so a graduate study course, postgraduate study course, in a master course like this? In the very beginning, students should be introduced in the goals, strategies, and designs for interdisciplinary Mars research. This should be an overview lesson before we go in some details like Martian geology. So Martian is very redundant here in this list, but climate research, of course, glaciology, polar research, exobiology, paleontology on Mars, also perhaps something like Mars geography, including mapping and site analysis. So we do this on Earth when we are asking to place a factory or something like this, yeah? Site or scale assessment for research and habitability issues, as we saw before in this talk of Dr. Carol Stoker. So comparative planetology would be another subject, and interdisciplinary master thesis dealing with a certain project in Mars research. The second academic program I would like to propose is a Master in Mars Systems Engineering. And in my point of view, we need systems engineers with a broad Mars mission-related engineering know-how, because another quote from Bob Zubrin from The Case for Mars: all it takes to go to Mars is present-day technology mixed with some 19th century chemical engineering, a dose of common sense, and a little bit of moxie. So this shows the systems engineering approach. So if we would like to qualify mission designers who are in charge of every part of the mission, so we should focus on this overview aspects, of course. So in the very beginning, students should be introduced in design and engineering, principles of design and destination-driven human missions to Mars. Then mission analysis and design is very important before we go into the details. Like Mars Aerospace Engineering 1, this could be launchers, interplanetary transportation systems, flight habitation systems, and their life support systems. Mars Aerospace Systems Engineering 2 could be re-entry, aerobraking, and landing systems, for instance. And another subject will be Mars Surface Ground Systems Engineering, like RCU systems, robots, also very important for the Germans, Mars balloons, ground habitation systems, and greenhouses. Mars systems operations and maintenance. This is a very important thing in my point of view because it enables us to design really life cycle oriented technology. Also project management. This should not dominate the study course, but it should be a module in this. And in the end, a master thesis with a Mars-related systems engineering project. So of course, students cannot be design and engineering experts in all technologies and all subsystems mentioned before, but they should be able to define the requirements for the specific technologies needed and integrate them into destination-driven approaches or missions. It should be mentioned here that we also need, of course, experts for technology and subsystems development, but our academic program should focus on a mission design and requirements analysis point of view, which should be unique, also the unique selling point of this study academic program. Last but not least, I propose that eventually the International Mars University should offer a PhD program in terraforming, which access for both master degree holders, interdisciplinary Mars research, and Masters of Mars Systems Engineering graduates, plus eventually external candidates with related master degrees. So the geographical presence should be worldwide in acquiring both students and, very important, I come to this later on, cooperation partners. The central source of know-how and thus the unique selling point are our cooperation, world-class teachers, researchers, and engineers from our partner universities and associated research institutions. The values are for sure, we share our general values in all academic institutions in the free world, like freedom and independence, in research and development and education. The specific value which is differentiating us, of course, from other universities is that we are committed to human Mars exploration. With all our activities, we contribute to the goals outlined in our vision. Economic goals, so this is, of course, a non-profit thing. And as a non-profit organization, we are focusing on long-term financial stability. So the most important thing, perhaps your primary question is there a market for an international Mars university? Although there are already numerous professors, chairs, perhaps institutes and departments dealing with Mars-related research and engineering issues at universities and, of course, at space agencies in the research field and other research institutions all over the world, I found no university or even graduate school which is totally committed only to Mars-specific science or engineering, even to human Mars exploration. Therefore, a direct competitor doesn't exist so far. Furthermore, the aforementioned chairs, institutes, and departments should be integrated into the concept as cooperation partners. So it's difficult to build up a university, and you have to rely, I said it before, to already existing resources. But could this International Mars University acquire students who would be willing to enroll for the proposed academic programs. So far, I did no empirical studies on this question. It's a very early phase. But in my talks about the Mars Society, in front of undergraduate students, also high school students, as well as Rotary and Rotaract clubs in Germany, many are, of course, excited about a Mars-related career, and thus, of course, in Mars-related specific studies. Therefore, I think that IMU, the International Mars University, would be able to create a new academic market with its described academic programs. Also, the number of jobs directly related to Mars is still limited, but hopefully growing. The students and PhDs would also be able to get excellent offers from other branches. So they can survive in the aeronautics industry, satellite industry, automotive industry. This is, I think, a little bit what Elon Musk does now. Yeah? He survives in other branches until the golden age of Mars breaks dawn. Yeah? So, what is the cooperative approach? So we should generally cooperate with already existing aforementioned Mars-committed institutions and professors, both for receiving excellent content. So we need, if we want to build up a university, we need some content. And also credibility for our program and eliminate competition or even rivalry. If we buy in the stakeholders, so we eliminate rivals, potential rivals. So everybody who is included and committed cannot be against this project, of course. But how should cooperative organization be set up in detail? My own experience with the startup and the growth process of Hamburg Distance Learning University, as well as a detailed analysis of the University of the Arctic, UArctic, which is also dedicated on a certain object, not Mars, but the Arctic, leaded me to the conclusion that we should start small and use resources of our potential cooperation partners by remaining in control over the curricular structure of our academic program. Not my structure I initially developed, but the structure later on developed by experts. This University of the Arctic, it's an interesting thing to surf on the web, so I put on the URL for this. The University of the Arctic is not a real or normal university by itself, but a cooperative network of northern universities, colleges, and other organizations. The members of this network share resources, facilities, and experience to build post-secondary education, that means postgraduate education programs that are relevant and accessible to northern students. Furthermore, UArctic is dedicated to interdisciplinary and diverse education, research, and the promotion of indigenous and local capacities and sustainable development in the circumpolar north. With over 130 member institutions, so that's a lot, and 8 Arctic countries and beyond, UArctic is, in its own words on this website, the North only truly circumpolar higher education institution and one of the world's largest education and research networks. Appointed individuals from the members form a council, and this council does all major decisions. The members provide also an active student exchange by mutually acknowledging the credit points or other members as long as it fits into the respective academic program. However, a student enrolls not at UArctic, but he is enrolling, or he or she is enrolling at a member institution and gets its degree also from there. So to sum up, UArctic has, in my point of view, positive and negative aspects for the strategic and organizational design of the International Mars University. The positive aspects are to use academic resources and reputation of cooperation partners, to create the possibility for students to study internationally at different universities by importing achieved credit points to their home university. Basically also a commitment to the Arctic as a common object of study and the integration of almost all potential stakeholders as member organizations or students. So there are, however, some negative aspects in my point of view. They are very difficult academic discussion and decision processes between members in a complex structure with bylaws, a council, and in the academic world, and this is part of my experience, possibly ultra-high transaction cost. Yeah, if you have always this kind of negotiation, which is of course necessary, but it costs you a lot of time and money. Members naturally prefer a bottom-up approach. That means that their individual module is more important for them than the goals and the structure of the whole or the entire curriculum and the academic program. Thus, impossibility to define a clear top-down structure of academic programs. And UArctic has, I mentioned this already, no own students. They give no own degrees. It's only an institutional network organizing the negotiation process between partners. So for designing an international Mars university, we should use the positive aspects and avoid the negative aspects mentioned before. This leads us to the following founding strategy and organization of the IMU. The strategic organization should be mentioned first. IMU should apply, of course, for an own university license and accreditation. I have some experience in Germany in doing this, but I'm not sure how this works in the US. So IMU should offer 2 master and 1 PhD program as proposed, should develop an initial structure of a framework for these programs, academic programs, ensuring the destination-driven approach. If we don't ensure this, this goes apart and goes into the sphere of our member or partner organizations. How should we ensure this? We should cooperate with world-class professors and institutes dedicated to Mars-related research and engineering, but on a customer-contractor basis. That means that IMU is the customer and buys in cooperation partners who get, of course, paid for their services in form of tuition fees or personally the professor on another different contractual baseline. Should provide e-learning elements where reasonable, and should offer truly international studies with placements of students at the cooperating partners institutes, with the possibility, of course, to import the achieved credit points they get there into our program. So the founding organization is quite simple. So it's a fundamental difference between those kind of big universities or battle stars I confronted you before. In the very first phase 1, which lasts among 2 years, IMU, the International Mars University, needs simply 1 founding president, and that's it, perhaps with a secretary, who should work out a detailed and credible business plan, establish initial contact to potential cooperation partners, prepare for university licensing and accreditation process, select founding deans for science and engineering. So we need a couple of people who are fixed employed in this university, but the main people are contracted in form of subcontractors. This ensures flexibility, of course. Yeah, so fundraising should be provided, of course, in the first 2 years. Later on, in phase 2, which lasts approximately 2 years, 3 scientific employees, founding president, founding dean science, and a founding dean engineering, plus eventually 2 or 3 administrative people are required to complete university and academic program licensing and accreditation. So in Germany we have not only a university accreditation of private universities, startup universities, but also accreditation process of programs, academic programs who have to undergo this. Negotiation and finalizing contracts with cooperation partners required for the first academic year, so we can develop the content little by little. We have to be ready first for the first academic years in the beginning. Developing e-learning and other content, of course, e-learning should be placed there where reasonable, and acquiring pioneer students for the science and engineering program. So after this founding phase, founding process, IMU should and could start in the first academic year. So those time frames are estimated by my experience in founding this Hamburg thing. Financial issues. Let's talk about money at last. So in the startup phase of almost 4 years, IMU has to rely on sponsoring money, so fundraising will be a critical issue. So in the very first phase, we need expenditures of $2 million. I transformed euros to dollars in a 1-to-1 ratio, so this is not true, but let's say a little bit more dollars here. The next 2 years, this should be increased to approximately $6 million per year, so this is an amount who can accept it. Later on, IMU should, in the growth process, be able to base its funding on the typical mixture of sponsoring money, and mainly, so in Germany, it's mainly tuition fees and not so much sponsoring money, but there are also, and there should be, hopefully, sponsors for a venture like this. So thank you very much for your attention, and I'm happy for questions. Thank you. Yes, sir.
You talked about partnering with research institutions and universities.
Yes.
You also talked about, for the engineering part of your program, partnering with manufacturing companies. There's some Canadian engineering faculties that have a fairly successful cooperative program where you alternate coursework with practical internships. And I think if those students could get work at companies like Lockheed Martin or at JPL or SpaceX, it would greatly increase their likelihood of finding a job when they graduate and make the program more attractive.
Absolutely. Thank you very much for this remark and this suggestion. So we should do this in form of internship, in form of practical internship, in the form of master thesis placements where the people can work in business companies or in industry, even in the space industry. Yeah, we should take this into account. So they are not able to provide credit points, or they are not able to provide academic tests or something like this, but we can place them there, and we should place them there, of course. Yeah?
Have you thought about making this university largely based on the online MOOC courses, as they're called?
Yeah, so it should be based on new courses so far, because otherwise we have a tough competition with other courses. But I think almost this kind of things I proposed. So again, as a layman, so we have to discuss this with experts, with faculties, and so on. But anyway, this Mars orientation is quite a new approach.
No, what I meant, I said MOOC. The massive online, whatever they're, you know, like Udacity, Coursera, so forth.
Absolutely. So we have to consider this because simply the knowledge, what the people read, should be delivered by this. Yeah.
One of the things that's kind of missing in your presentation is the social potentiality of this particular kind of organization. In particular, all of the successful programs that have been discussed this week had a common goal of the people in the program working as part of a team. And so when you mention, for instance, a master's thesis, there should be the ultimate requirement that that not be a person master's thesis, but a team master's thesis. Would you comment on that?
So that's completely right. So I left out completely those kind of things like giving talks, presentation, like socially working together. This was only a suggestion or a proposal in terms of the the content, the content of the lessons, but we should not only take this into consideration. We should and we have to implement this there, of course. Yeah.
Whoever you like. This gentleman?
Yeah, it's not clear to me what are the next steps. So what are you going to do?
Yeah, so I'm pretty much interested in further developing this, and I already talked to one professor, Stuttgart University. He was working originally for us too in Hamburg on a contractual baseline, and we want to discuss about this. There are, of course, different possibilities to organize this. So a network could also be taken into account, simply a network where we network with other universities to propose Mars-oriented degrees, or a graduate school and in an already existing university could also be a model of this. Yeah, but I think my experience was developing something privately from the very first startup phase, and I want to present it here, because if we are in charge of the organization, we are in charge of some basic curricular structures to put this thing towards human exploration. If we are leaving this to other people, to cooperation partners, then there is a kind of compromise which is also okay in the academic world, but it's not this kind of goal-driven, destination-driven approach we have here also in this society. Yeah.
Hi, I think the idea has real merits, but I've got a question about an alternative. Given that most established universities do offer possibly dozens up to hundreds of different undergraduates and master's courses, as an alternative, would it not be easier to develop Mars-oriented science and engineering courses and try to popularize them at existing institutes? So I guess the real question is, what is the benefits of a dedicated international Mars university?
So I think this is absolutely important that we don't stop outreach work in university or do, for example, rover projects, or in Germany, Mars balloon projects with universities. So, but this does not lead us to a conclusion to the problem that we have in this critical phase, bachelor's, master courses, floating away people who are or were originally interested in Mars-related topics to some other things. So you could not avoid this completely, even not with an international Mars society, Mars university. But undergraduates or even high school students are very interested. And my experience is that we later on have the problem that the people disappear continuously, and later on they are critical engineers, so we need critical engineers, but they are critical to everything, so they say as mainly what is not working. And this is my experience, so therefore we should have an institution, or we should go for an institution who mainly is committed to this goals, not in a competitional force to the other activities on universities, which are very valuable and should be continued. Yeah.
Well, I really applaud your vision, and I really believe that this is necessary to build the IMU. But what I want to ask you is, why do you want to reinvent the wheel? Because we already have the very established, successful International Space University in Strasbourg, France, which is, for the last 20 years. So I would like to propose to you, maybe you should cooperate with them and work with them to develop this program, the programs that you have proposed here, the academic program, and integrate it with them so that they can actually offer it through their university. Or you can, if you don't want to do that, what you could do then is be a sub-university or institute that's working with them, but offering this specific Mars academic program. Because they already have the business structure model, very successful.
So ISU will be one of our first addresses to propose things like this. So don't stick too much on this organizational outline I gave you. This was just our initial argument to get into the discussion. Of course, ISU would be one of the ideal not only partners but institutions to carry out this. So there were already summer schools and conferences at ISU on Mars-related topics, of course. But again, our goal should be to establish wherever human Mars exploration-oriented program which drives this issue forward. Yeah?
Okay, 2 quick questions and quick answers.
Yeah.
You've mentioned quite correctly that Mars exploration is a very complex endeavor requiring people from lots of different areas and international working together. What I would ask is whether management of virtual teams and management of teams across disciplines and time zones will be a strong feature of this university.
Right.
It's something that all of us who work professionally in space exploration run into time after time, and it could be a real strength of the International Mars University. Also, it would be I think necessary for you to master that in the initial stages of organization, because as you know, getting academics to do anything together is like herding cats.
Right. Yeah. So, short answer. I completely agree with this. We have to work on this, and this is a tough issue. Of course, we had even this problem at Hamburg University of Applied Sciences, where some students are working presently in China or elsewhere, and they have to do written tests who are at the same local time in Germany. In Germany, we have only one time zone, yeah, and therefore, this was a challenge to that they don't interact during the tests, yeah. So we have to work on this. Very good remark, yep.
Okay, quick question, quick answer.
Hi. Given the accelerating costs of education in the United States, given the accelerating costs of education in the United States and the differences in cost abroad, might that affect your initial selection and guidance to students for partner institutions?
So I didn't get the last part of your...
How does cost affect your choice of students and cooperating institutions?
So we have this little stuff in the initial founding phase, and this alone for itself guarantees for cost effectiveness. If we have 3 academic people who do all this cooperation partner networking, this is cost effective, plus we have travel expenses, of course, and we have, of course, the development costs of the materials, and this adds up to about 6 million euro per year in the founding phase. So this was a calculation pretty much based on German private university startups, not on the US. So I'm not in charge of US data and cost there. I think it's a little bit higher, yep?
Okay,
Okay,
thank you.
Thank you very much.